Hello teacher, today I'm going to do my machine learning homework and this is our file. Those are the macros files and there are examples of the data. This is the linear regression. For the journal, I'm just choosing the Python. Okay. And in here, first of all, we are just running the cell, importing the NumPy and matplotlib with utils.python file right right here, and we are just importing this one here. uh, and suppose you are the CEO of the restaurant franchise. uh, let's run it first of all. Suppose you are the CEO of restaurant franchise and considering different cities for opening and a new outlet. You would like to expand your business cities. Uh, it may give you higher profits. The chain already has restaurant in various SDS, data for profits. For these cities, you have the city population. You can use data help to can you use data to help to identify which cities may potentially given your business high profits. And we're gonna loading the data set in here. We are just loading data sets X-train and Y-train like that. I'm not sure where is the load data. It could be in here. Yes, right here. Load data, and load data makes X-train and U-train. And util we're just data x1 and x data. We are just importing these things in here. Before starting a new task, it's useful to get more familiar with your dataset. A good place to start is to just print out each variable and see what it contains. And code below X-train and type of variable. Okay, just it has a 5 trains and 6.1, 5.1, 5.5, 8.57 and 5.8. We can actually make the U-train for it also. It didn't run actually U-train, but this is the same. Am I making a mistake? I have to change this one also. And like that, it changed it. I'm gonna change remake X-train. Let's run it. Okay. Actually, it writes the Y train here, and NumPy array contains non-decimal values that are greater than 0 represent the city population times 10K. For example, 6.1 means the population for this city is 661. Similarly, U-train is a numpy that has some decimal values, some negative, some positive. Actually, there are no negative right here. Let's look at those datas. This is the x values and this is the u values. I'm remembering from there, from here. The left side is the x values, right side is the y values. And also we got the negative values like that. And these represent your rest average amount profit in each city in units of 10K. For example, 17.5 represents 75,100. Sorry, 175K average month profit for city. And check the dimensions of variables like here. The shape of x is 97, and actually this is comparing the only the profit per city with the population with the city. The population array has 97 97 data points, and the monthly average point also has 97 data points. These are numpy 1D arrays, one dimensional arrays actually. Visualize your data. It's often useful to understand the data by visualization. For the dataset, you can use a scratch plot to visualize the data, since it only has two properties: is the plot profit population. Many other problems that you will encounter in real life have more than two properties. For example, population average wholesale income, month profits, month sales. When you have more than two profits, you can still use a scatter plot to see relationship between each. Let's run it. In here, if you are seeing displaying the scatter plot, which is populations and profits with the x and u levels or compare, we are visualizing the one, and the goal is build a linear regression model to fit this data, and it's and with this model you can input a new city's population and have the model estimate your restaurant potential multi-office for city. and refresh on the linear regression. In this practice lab, you will fit the linear regression parameters W and B to your dataset. The model function for linear regression, which is function that maps from x map x to u x, is which is a city population, and use the rest must multiple of it for each city represents the function w and x equal to w times x plus b. Train a linear regression model. You want to find the best WB parameters and that fit your data. Set compare the how to choose of WB is better or worse than another choice. You can evaluate it with a cost function j of WB, and j is a function of WB that is a value the cost of j and WB depends on the value of v and b, and choice of the W and B that fix your data set best in the best in the one that has smallest WB to find, and WB that get the smallest possible cost J of WB. And you can use a method called gradient distance, which each step of gradient your parameters WB come closer to optimal values that will achieve the lower cost J of WB train linear regression model can take the input values x for S population and the output of prediction function VB of x predict amount profit for restaurant in that city. In the part 5 we are just comparing. Okay, we was in the 5. Yes, we are computing the cost gradient. Each involves represent steps to adjust the value of parameter VB to gradually get a smaller and smaller J of VB, and each step of gradient distance it will helpful for you to monitor your process by competent to just J of VB gets updated in this section. You will find you will be a function of calculus JV. You can check the process of gradient distance implementation. The cost function is made from lecture for one variable C function linear regression, and JVB is defined as here. And you can think of function BB XOI. This is the model prediction of your resistance is supposed to over I, which is actually profit that's in recorded in data and is the number of training example datas, and model prediction for linear regression with one variable. The prediction of model VB, for example x or e, is represent as here, and this equation for a line with intercept b and a slope of b. And for the implementation, complete to complete cost of function and exercise found to complete call below to here actually mathematical function summation method. We can run it to compute function. If you get stuck, you can check the hint after the sale with the implementation. Let me run it. Click on the hints what's here. Okay. Click for the hints. Okay, this is the hint. We can check the implementation was correct running following test codes. Okay. And these these are error because I haven't changed anything. These are hints actually. And uh, this is the args and we haven't defined it and the other stuff. And I will gonna solve this methodology then and showing how I am doing. And let's start from here. Total cost is equal to 0 and start code from here and code from here. Okay. First of all, I have to define a predictions. Okay. Predictions. Predictions equal what will gonna happen. W W and X plus B, and after that what will should I do? Squared errors. What will gonna happen? Predictions and predictions minus y and 2, and after that what should I do? I have to define the total cost equal to uh, let's open it and 1 like that, and after that I have to return the total cost like that. And here I haven't run actually, but I just defined the W, X and B for the predictions. Where is here? And predictions we are here. that represents wx and plus b, u and square root equals this part, and we are just adding the 1 divided by 2m summation to root, and this is the square root we are taking in here. Then I will run it actually. Then I am gonna come run in here. All tests are passed. Cause initial v zeros 75.200. This is the gradient distance, how we are rising it, like that. Actually, I shouldn't read all of them, but I will in this section, I will implement the regression for parameters WB for linear regression as described in the linear lecture videos. Gradient descent algorithm in both parameters WB are both updated simultaneously, and where m is the number of training examples data in here. And you will implement a function called compute gradient, which calculates, and this is the exercise to complete a gradient function to iterative over examples, and each example complete the prediction of the model for the example. The gradient for the parameters WB for the example return total gradient update from all examples, and here m is the number of training examples, and summation operator. Okay, if you guys stuck, you can check into present after the cell. And right now I'm gonna solve this problem. Okay, let's start the start code from here. Okay, uh, first of all, I have to define a for loop for I in range m, and after that I have to define a prediction prediction sorry prediction should be equal to w x I and plus b, and after that I have to define an error section in here. Error section prediction and minus yi. Okay, and after that I have to use this example. Let's copy equals plus equals error sorry error and x and I, and after that I have to use this sample, and after that what should I do? Dividing by. Okay, dividing by and equals, sorry, dividing by and equals m. And after that, let's just click on it. Okay, and after that, returning. And let me explain what I done. In here, if we go fbb x over I equal to 2bx, and this is was first function in here, we give it as a prediction, so we are just right here, and again prediction and error prediction. This is the error prediction for the second part of it. This is taking this one and this one minus u, and for taking everything, and this was the zeros, and we are using the error x by finding the every step like that. Actually, I explained about it, I got it. And there are some errors. Let me check it. Hmm, MX shape. hmm Range M predictions. Error prediction minus B error all access, and there is no error, I think, but when I start this, I am getting error. And gradient descent algorithm. And in here, learning period using the batch gradient distance, you will now find of as linear regression model by using batch grids. Descent refers to running all the examples, in one iteration. You don't need to implement anything for this part. Simply run the zest blow, and a good way to verify gradient distance is correctly and look at the value of J and B for the reason which step. Assuming you have implemented the gradient and completed the course correctly and you have prayed well for learning, and should will never increase, should converge to state values at end of. Let me check it. This is working, but this is not working. Sorry, this is actually working. Now, these are the iterations, it's just running the same as again. Again, and we are finding the accepted output will be the found to grade by the gradient distance in here. And we will now use the final parameters from distance to pilot the linear fit. We recall that we can get the prediction for a single example. To calculate the predictions on the entire dataset, we can draw out the all training examples and calculate the prediction for each example. This is shown in the code. We are just running it and predict the linear fit. As I said before, and the final values of VB can also to you make prediction on profits. Let's predict what the profit will vary as 35k and 7k. 70k people. The model takes the population for each 10k as input. Therefore, to the 5 can be transmitted into output models array numpy array 3.5. Similarly, 7,000 people can be translated into the input model as numpy arrays 7. If we can run this one for the one total to 5k population, we profit and profit things, and we are taking those values. This is the end of the season. Thanks for listening.